and welcome to the latest episode of Pioneers, Siemens Startup Podcast Series, where we speak with entrepreneurs to gain insights into how they turn their innovative dreams into successful companies. I'm your host, Kevin Blevins. There have been a number of technological advancements that have changed society's relationship to acceleration, space, and time. Consider this. Once upon a time, our primary mode of transportation was horse-drawn wagons until the advent of steam engines, which revolutionized travel. Steam engines paved the way for emergence of locomotives fueled by fossil fuels that connected cities, nations like never before. Eventually, cars and planes took flight, granting an unprecedented mobility and freedom. These current modes of transportation are available to everybody. Reflecting on these advancements, it becomes apparent that significant infrastructure was required before widespread adoption could take place. A network of railways, roads, airports had to be constructed, along with refueling stations for both the vehicles as well as the people driving those vehicles, right? Repair shops were needed to ensure the journey could continue, and all of this shaping the course of human progress. If we turn our focus to the present, we find ourselves in the midst of a significant surge in the commercialization of space. While some say that commercialization of space began with SpaceX's inaugural rocket launch, the story runs way deeper. According to a report on the Federal Aviation Administration website, space commercialization traces its roots back to 1963, when NASA, under the Department of Defense, or the DoD, contracted for the development of a vehicle for launching telecommunications satellites into space. Fast forward over 3 decades to August 7th, 1995, when the Department of Transportation, DOT, announced a pivotal shift. The Office of Commercial Space Transportation transitioned from the Office of the Secretary to the Federal Aviation Administration. Yes, the FAA, the same government regulatory organization overseeing air travel today. This transfer paved the way for much of the space exploration that we are witnessing today. Just as the advancement of locomotives, cars, planes required substantial infrastructure development, the commercialization of space follows suit. We stand at the precipice of a new era where the pursuit of space exploration will demand robust systems and infrastructure to support our ambitions. Today, I'm excited to be speaking with Rahul Ragani, Chief Systems Engineer at Arcasys, Inc., a US-based startup company developing space infrastructure. They're developing the first ever business platform in space for new technology hosting of satellite integration, assembly, and resupply. So they're addressing some of the infrastructure issues space exploration will need. Hello, Rahul, and wonderful to speak with you, and very much appreciate you taking the time to join us today.
Hi, Kevin. Thank you for the invite. I'm happy to be here.
So, Rahul, I'd like to start by learning a little bit more about yourself. Can you tell us about your background and what has brought you to where you are today?
Yeah, of course. So I have a bachelor's degree in mechanical engineering and master's and PhD in astronautical engineering from USC. During the course of all that education, I focused my studies on satellite rendezvous proximity operations, that is, the use of multiple satellites to perform activities and construction in space. So currently I'm the Chief Systems Engineer at Arcasys, and I joined Arcasys about 4 years ago, shortly after it was founded. I was recruited by the founder of Arcasys, Dave Barnhart, when we were working together at USC while I was doing my PhD.
So you were focused in your master's and PhD around space and things of that sort, which were critical to the whole idea of space infrastructure. So what was it about Arcasys that was interesting and drew you there?
Arcasys was developing something quite interesting and unique, a platform that payloads can be hosted on and reconfigured in space. Current space platforms are monolithic satellites or even small satellites, but they serve a singular purpose. They're not designed to be reused or repurposed after their mission is done. When I joined Arcasys, I was drawn in by the opportunity to design a system that can be reconfigured after launch. We can send up new modules, new components, upgrade everything, every piece of the spacecraft at any time we want. So we're chasing a modular architecture.
It's a modular architecture that's going to exist in space. And how is that different than a space station that exists today?
This is on a much smaller scale than a space station. So I guess the International Space Station it's huge. It's more than the size of a football field. It's massive and it requires astronauts, like dozens of them over the course of years, to maintain it. What we're working on is something on a smaller scale, about 3 meters or 10 feet across, with robotics on board. There will be no people on board, no astronauts, but it'll be entirely robotically operated. So we can reconfigure with commands from the ground. We can have new payloads docked to it. We can even, in the future, refuel other spacecraft from a fuel depot on board.
And so your ability to reconfigure this, I'm visualizing a pod that exists out in space with robotic arms on it and then areas where crafts can dock to it. Is it a single pod? Is it a combination of pods that come together?
We'll be starting with a single pod. Our building block is a hexagonal shape to allow us to grow. And then at future launches, we'll send up more of these hexagons. We call them port modules. And they'll attach to each other to expand the whole structure. So we can aggregate many of these port modules together to make a larger port structure.
Okay. And that's where the whole idea of reconfiguration in space comes from?
Exactly. And the main idea was to solve a problem that we saw in the industry. The large government contractors, the DoD, DARPA, even NASA, Air Force, all of those entities are requesting new technologies from smaller companies. However, they will not fly technologies that have not been proven in space. NASA especially will not take anything that's above a TRL 9. So in spacecraft terms, there's something called a TRL, the technology readiness level. This ranges from 1, which is just something you designed in CAD and haven't even built yet, to level 9, which means it has gone to space, flown in space, you've tested it, and it works in space. So anything above a TRL level 6 has to have flown in space before. We're offering a service for these smaller companies that want to test their equipment in space, get themselves to a TRL 7 or higher for a fraction of the cost of building their own satellite. So imagine like a storage facility. You go rent a storage unit and they provide you with power. You can plug in your equipment. You have lights. You can store all your stuff in there. And you only pay for, let's say, 3 months at the storage unit because you only need it for 3 months. We're offering the same service in space, where on our port, you can attach your payload for, say, 3 months or 6 months, however long your mission is, to test your technology. And then when it's done, we will dispose of your payload to attach a new one on board. All the while, we provide power, we collect your data, we send it, and we collect it, bring it down to the ground, we send your commands up to the spacecraft, and all you have to do is view it in a web portal.
I mean, this sounds like an incredible amount of infrastructure for me. I mean, you're sending something up, but there's way more to it than just having the port module in space. It's all of the electronics that have to be on board. It's all of the compute power that needs to be there. It's all of the communication to and from Earth to the port module. There's a significant number of pieces there. And I'm not sure that, just anybody's going to recognize that, but I find that pretty fascinating. How far along are you? Where do you stand today in some of the activity that you're working on?
Yeah, so at this point, we've completed the majority of our ground testing. We've built a full-scale mock-up of our spacecraft and have robotic arms on board demonstrating reconfiguration of payloads, accepting new payloads, and powering payloads through space-rated interfaces. Our next step is to build out the flight unit so that we can launch it early 2025.
When we started talking earlier about Arcosys, I mentioned that it's the first ever business platform in space. Can you help people understand what you mean by business platform?
Yeah, of course. So when we talk about Arcosys as a business platform, that is a place where you can host payloads in space. You can not only host payloads, you can rent other people's payloads. So Let's say you've developed a novel new camera. You want to test it in space. You send it up on our platform. We host you for 3 months. You test out your payload. You've got it to TRL 7 or 8. Now you're ready to sell that to NASA, DoD, whoever wants these new features. At that point, you can open up your payload to our business marketplace. Rather than taking your payload off and deorbiting it and letting it burn up in the atmosphere, we will sell your payload capabilities to anyone else who wants to use it on the port. And we facilitate this so that it's still attached to the port, and we sell other users access to your data. So let's say there is another company hosting a payload on the port at the same time that is developing an imaging processing system. They want to test it with an actual camera in space. We put them in touch with you guys, and we can pass the data along internally in the port.
Oh, between different payloads. Okay.
Exactly, and with permission, of course, from each party.
Oh, sure. That kind of goes without saying, right? Everybody's got an NDA.
Yes.
Okay. When I think about this again, it seems pretty daunting. And I can't even imagine where to start. And it sounds like you've got a good footprint. You know what the space is going to look like. You've built that, and now you're getting ready to launch it. Once it's launched and it's in space, and I want to do a project on your port module, do I have to align my own launch process to make sure I'm getting my project into space?
So we handle all of that. We have some partners with companies that provide orbital transfer vehicles. So we set you up with a ride share, and we'll get at least a half dozen of payloads at a time, put them on an orbital transfer vehicle, and this will go up on a SpaceX or a Rocket Lab launch or whatever is the most convenient at the time. And then the orbital transfer vehicle, the OTV, will take the payloads from the SpaceX upper stage and transfer them over to the port. It'll come up to about within 1 or 2 meters of the port. It won't hard dock with the port, and our robotic arm will grab each payload off of the OTV and attach it to the port.
Ah, okay. And when it attaches to the port, how does it attach to the port?
So we have 2 types of interfaces. There's one called the UDA, the Universal Device Adapter, made by a company called NovaWorks, also here in the SoCal area. And then there's another one called the ISSI, the Intelligent Space Systems Interface, built by a company called iBoss in Germany. These are the 2 prevalent interfaces that we've decided to include on our platform. A customer who signs on with us, depending on what the requirements are, will choose the interface that has the best fit, depending on how much power requirements and the mass. And then in the price of renting the slot on the port is included the interface. So we will mail you one of those interfaces to incorporate into your design. And the interface is not just mechanical lock. It also provides data and power pass-through, and we can transfer thermal loads for heat rejection so that we can take the heat that your component is generating and radiate it off to space.
Interesting. So do you have to ask permission to launch your port module into space, and what is wrapped around that, I guess?
So anything that launches into space needs to get a license. There's 2 types of licenses involved. One is the launch license, and that is in the US handled by the FAA. So in that case, let's say we're launching on a SpaceX vehicle. SpaceX handles all the launch licensing because they're the one who is operating the rocket. And they then, in turn, collect information from every payload to make sure that they're compliant. Each payload is compliant with FAA regulations. So for the most part, SpaceX or Rocket Lab or whoever we would launch with would handle the launch regulations. The other regulations are from the FCC. So anytime you want to do any communications between the space and the ground, you have to get a frequency license. In the US, that's handled by the FCC. Each country has its own designation for that. There's an equivalent in Europe, within the European Union. For the most part, you can apply for that on your own, but the majority of that is done by what's known as the large telecommunication constellation operators. One of the biggest ones in the world is called KSAT, and they're based out of Norway, but they have ground stations all over the world. So what we would do is contract with KSAT or Atlas or one of the other ground network operators, tell them, we have the spacecraft going up. We want to get data to the ground. We don't want to operate our own network of antennas. We contract it out to them. They have hundreds of antennas across the world, each already having licenses in their specific countries. And we would just need to obtain an FCC license to transmit.
And I'm assuming you're creating partnerships like this for different aspects of what you're doing.
Exactly. And the way we're handling it is, since all payloads will be attached to the port, they will be, from a regulatory point of view, one spacecraft. So each payload does not need to get a separate license. They are communicating through the port's antennas. So we will already have a license for that.
You are the chief systems engineer for Arcasys. Not everybody knows what a systems engineer is. Might you share a little bit about your background in systems engineering and what that role as systems engineer is?
So I was first introduced to systems engineering while doing my master's at USC. I was part of a student team building a CubeSat, a small satellite about the size of a cereal box that the university was funding to send up to space. When dealing with a satellite mission, or really any sort of engineering project, you'll have a team of mechanical engineers, someone doing analysis, your electrical engineers, your communications engineers. And encompassing all that is the systems engineering team, or with a student project, just one systems engineer and one RF engineer, one mechanical engineer. But the systems engineer has the role of coordinating with all the other engineers, as well as setting the mission guidelines. So while a mechanical engineer would be working on the structure and designing it to survive certain loading during launch, and a communications engineer would be figuring out how to get all the data to the ground, and the electrical engineer is working on the power system, the systems engineer is setting all the requirements for that, working with the customer and the engineers on the subsystem level to make sure that all the requirements are met. So, for example, the systems engineer will work on the orbit of the spacecraft to make sure that you can generate enough power and know when you'll be able to communicate with the ground and relay this information to the various subsystem teams. The systems engineer will also work with the customer to determine how much budget there is for launch, what is the maximum mass we can have, and then make sure that the spacecraft sticks within those goals.
So in your role, do you look at all of those different pieces, bring together, whether it's current, flow, or power needs, and bring all of those together to make sure the entire system of systems has everything that it needs?
Yes, exactly. As a systems engineer, I'm working with everyone on the team to make sure information is flowing properly and the design is coming together as it should.
I was going to ask a question earlier about the Arcasys name. So a lot of the startup companies, there's some significance to the name. Is there a story behind the Arcasys name?
Yeah, it's more of a shortening of architecting systems. So we're putting things together, we're combining different customers' payloads and different technologies that have not been used in this way before. So we came up with the name Architecting Systems.
So does Arcasys have specific projects or initiatives that the team is working on in the development of this business platform right now? We talked about the fact that you're building the port module, and now you're starting to work toward some of the launch and what you're going to need from a launch perspective. What other projects are you working on?
While we're doing that, we're also working on improving our electronics capabilities and our computing platforms so that they are more radiation tolerant and we can have a more resilient system that can grow. One of the challenges we've been working to solve is, how do you handle the communications when you have multiple port modules that come together and then now you've just, say, doubled or tripled your compute capacity, you have to restructure how you're distributing the load so that it's distributed evenly. Especially when you're adding new sensors, you have twice as many thrusters now, you're changing your center of mass. So all of that is software we're working on how to control a system that can grow.
And then there's the integration of the compute power itself. You have one computer on the first port, and then you add a second port. Now you've got to make sure that the two computers are communicating. I'm assuming it's going to be multiple computers, or is it going to just be the one?
No, it'll be multiple. In each port will have multiple computers already.
Oh, okay. Yeah, and the communication amongst those computers is going to be really important, not to mention whoever's sending the payload up, right?
Yes, exactly.
Earlier this year, I saw an article related to Arcasys and the U.S. Space Force. Is this something that you can talk about? And if so, could you share what's going on?
So Arcasys has won a direct-to-phase 2 SBIR, that's a small business initiative request, with the U.S. Space Force. So this is a contract that they work on with small businesses like Arcasys or other startups to improve a technology that is either existing or in progress. So for this contract, we have been working on demonstrating robotic reconfiguration of our spaceport. So I had mentioned that we were currently doing robotic demonstrations. That's under this Space Force initiative. So that's what's happening. In fact, we have our next test next week at our lab, where we're going to be taking a robotic arm, moving some payloads around using actual space-rated interfaces on board a full-scale mock-up of our spacecraft. So the exterior is exactly the same as the flight version, but the interior is not flight components. And then we'll have the robotic arm moving things around to understand how that will work with active payloads.
You talk about your lab. Where's your lab located?
We're in Los Alamitos, just near Long Beach.
And you have a new facility that's either opened or opening. Is that correct?
Yeah, that's this lab I'm talking about. So we have lab and office space in the same building. And we just acquired this new facility back in end of March. So we're having a big open house in the coming weeks.
Congratulations on the new facility. I think that's wonderful. Good for you. I know that when we met a while back, you were talking about being excited to get into the new facility and things like that. So that's great. I saw something on your website that mentioned and talked about on-demand manipulation and build. What does that mean?
So one of the services that we are striving to offer is the ability to deploy a custom satellite within a few days on orbit. So in addition to setting up the components for the port and any payloads attached to it, we're sending up some small satellites. These are small building blocks that include cameras, radios, anything you need for a satellite, a power system, solar panels, that we can plug into each other, sort of like Legos, and deploy them from the port to become its own entity. So if you were the US Department of Defense and really wanted to get something out there quickly, we would offer a service that we can assemble this small spacecraft, send it out within a week of you putting in the request, and then you can take control of it.
Yeah, that's interesting. I also read something related to safe and standard visiting vessel, RPO, but unfortunately, I did not understand what RPO is, and so there's probably somebody else out there who doesn't know either. So can you tell us what RPO is?
Yeah, in regards to spacecraft, RPO is Rendezvous and Proximity Operations. So that's the act of two spacecrafts coming together and either performing operations in close proximity or actually hard docking to each other. So part of our business model is to have OTVs, orbital transfer vehicles, come and approach the port, and then we transfer payloads from the OTV to our port. In this case, there's no hard dock. The OTV does not physically contact the port. We just get it close enough that the arm can reach across and grab the payloads. But it's still a form of RPO because we have to negotiate with this vehicle the trajectory that they're going to approach on, all the speeds that they should be at, some hold positions we can make sure that in case something happens, we don't crash into each other. And all this is defined in our RPO Visiting Vessel Handbook that we published last year and is available upon request on our website. Any company interested in performing RPO with Arcasys can request this handbook, and they can see the set of guidelines we've put together.
Okay, great. Well, that's interesting. It's nice to hear that you've got the handbook out there, and then if there's anybody listening out there who has something that they'd like to be able to do in space, this sounds like a great opportunity to be able to do that. When I think about what you're doing to help one get people's project into space, and then you're going to house that activity, and then you're going to give them all the compute power, you're almost a one-stop shop for experiments in space. How are you going to monetize this with your customers? Is it just going to be a buildup of cost, or is this going to be a platform as a service scenario?
Yeah, so we're definitely taking a service-based approach. So customers who want to have their payload on board the port will pay a monthly fee depending on what services that they want. So there is a base fee to get launched up that we will coordinate. And then for every month you remain on the port, we have a fee based on a tiered level. We'll have different tiers based on how much power and data you need, and as well as what your payload mass is. So let's say you don't need full uptime 100%. You just want to run your experiment for an hour every day. You would be on the lowest tier. You would have a discount savings in the fact that you're not constantly using power and turned on all the time. Whereas if you had a camera, you want to be taking video all the time, then you need power all the time. So you'll be in the highest tier, being powered on all the time.
Is it fair to assume that everything that will be done related to power will be solar power?
Yes. We have deployable solar arrays that provide up to 2,000 watts of power when they're aligned with the sun. But it'll all be solar. We're not doing anything nuclear on this flight.
That's part of why I was asking. I was curious if you were looking at some of the newer technologies to drive power in space.
No, but we are excited for the companies that are developing nuclear systems for space and hope to use them one day. But right now, the regulatory red tape and the technology is not quite mature enough.
We'll let somebody else worry about that first, right?
Yeah, exactly.
Just out of curiosity, is there a concern about the amount of space trash that exists in space today and what you're doing?
Oh, definitely. There's definitely a concern that space trash is growing, and we take every effort to not create more space trash. From start to finish, the port is designed at the end of its life, well, whenever that may be, to deorbit itself. But we have many payloads on board, so we can host up to 60 payloads at a time. But when these payloads decide, we no longer want to be in space, we finished our mission, we are able to round them up and safely deorbit them within a period of a few years, even a few months, maybe. It really depends on the size of the payload, but we have a little spring-loaded system to launch them away from the port at the velocity required to slowly deorbit them. And even at the altitudes we'll be at, this is about like 400 to 500 kilometers above the surface of the Earth, there's still some atmosphere. So over a period of 2 to 3 years, anything we launch off of our port will deorbit on its own.
As it's deorbiting, will it just burn up in the process?
Yeah, it'll burn up.
It will burn up. Okay. What is the biggest and most challenging concern that you might have today?
I guess our biggest concern is radiation and the unpredictability of how radiation works. It really depends on the solar cycle as well as the altitude you're at and even where you are over the Earth, because the Earth's magnetic field is not uniform in blocking radiation. So we have to provide enough shielding for our components, but every piece of shielding we put is extra weight. So it's a trade-off between, can we accept some loss of components due to radiation, or do we need to spend extra money to shield things? So radiation always worries me, but there are ways to mitigate the risk.
I would have thought it was something mechanical or electrical or something like that. I didn't, but I understand. And then there's the whole thermal side of what happens in space, and it's a whole lot different than it is down here on Earth. Another question I had for you was a couple of years ago, there was a significant sun flare. It was finally starting to reach Earth, and then all of a sudden the aurora borealis is going crazy. And in the United States, some of the middle states can see the aurora borealis for the first time. So I was just curious if this impacts you as well.
Yes, it definitely impacts us, but we're not so much worried about the flares themselves as we are about the secondary effects. So right now we're actually in a solar maximum. So the sun has an 11-year cycle where at a solar maximum there are more solar flares, solar minimum there are much fewer solar flares. So at a solar maximum, the sun is spewing out more charged particles through these solar flares. When these hit the atmosphere, it also causes the atmosphere to actually swell up a little bit. So at our orbit in low Earth orbit, it would actually be a bit higher density of atmospheric gases. So the good thing is we'll be launching after a solar maximum, so every year we're out there, the atmosphere is shrinking a little bit, meaning our spacecraft would last longer. What would be harder is if we would launch maybe like 5 years ago, and now we would be operating in a solar maximum.
Oh, now I have to research solar maximum. That's an interesting concept. That's what happens when you're just a mechanical engineer and not an aeronautical engineer, right?
Exactly. And the solar flares themselves, they can cause problems to spacecraft with the charged particles, but there's not much you can really do to protect from them other than the normal radiation shielding. If a giant solar flare does hit, it will affect all spacecraft equally.
Raul, if you had a crystal ball and you could see out 3 to 5 years, what will Arcasys accomplish in that time frame, and what new initiatives do you think you will be working on?
In the next 5 years, we hopefully will have a port module up in low Earth orbit with payloads on board. But at that point, our next goal will be to enable in-space manufacturing. So the long-term goal is to have the ability to build large structures in space. Right now, the limit on what you can build and send to space is constrained by the launch vehicle. You have to have it fold up inside the rocket, and then you deploy it and unfold it in space. So imagine the James Webb Space Telescope. It had to launch on the rocket with the largest available fairing size, and even then, it took them years to figure out how to pack the whole deployable optical system into that small volume. Imagine if instead we could just send up the core components and build the reflectors in space. You can build the antennas in space, the things that take up the large volume that you have to fold up in a launch vehicle. What if you can just build it in space? That is our goal. And we're working with companies that are planning to do orbital mining of asteroids, bring back raw materials, and actually smelt them in space to make metals and extrude and 3D print components.
And just so our audience understands, when you talk about building large things in space, how large are we talking about?
How large do you want? We're talking about things on the order of when I say large, I mean like hundreds of meters across.
That's interesting. So will there be a second generation of the port?
Yes. We don't know yet what that will look like, but we definitely plan to learn from the first port to see what we need to upgrade for more resiliency in the second generation port vehicles. But also, 5 years from now, we could have whole new technologies available that don't even exist now. So I don't know what the second generation will look like, but there definitely will be a second generation.
Yeah, things are changing very quick today, aren't they?
One of the things changing quickly that'll hopefully be available in 5 years' time is optical communications. Right now, the majority of communications between spacecraft and ground are radio communications. But there's only so much bandwidth you can have on the radio spectrum, and it's becoming quite full. But you can have laser communication links between a spacecraft and the ground, and a few of these have been demonstrated in technology experiments with hundreds of gigabits per second of communication speeds. We hope that in 6 years, that this is commercially available, so we can have a laser communications terminal on board our spacecraft to send terabytes of data down to the ground every day.
Very interesting. But, we were also talking about the power on board and it being solar. Do you have power storage devices on board, batteries of some sort as well?
Yeah, of course we have batteries on board. So given the orbit in low Earth orbit, we orbit once around the Earth every 90 minutes or so, and about half that time is spent on the far side of the Earth, so in an eclipse. So we have to generate enough power while we're facing the sun to charge up the batteries and then run in eclipse.
So do you think new battery technology that's coming out will be helpful as well?
Yes, I sure hope so. However, with past experience, battery technology making its way to the space sector takes a bit longer because they have to be tested for radiation once they've been developed. And there's different circuitry involved with the radiation requirements in space. But I hope that new battery technology available today will start the qualification for space testing.
That's great. Well, if nothing else, people will learn a lot of things they didn't know about space. And they're probably second nature to you, but I've learned a ton. Well, Raul, in case we have any budding entrepreneurs or people who want to work for a startup, do you have any advice for these people?
Yeah, so when you have an idea, keep shopping it around. Don't be discouraged if the first VC or the first incubator doesn't take up the idea. If you've done your market research correctly and you think that it's viable, keep shopping it around, but also don't get stuck in a rut. Modify your design to meet the market as it shifts.
That's good advice. That's a common theme that we've heard from other people who are working at startups as well or have created startups. Switching gears a bit, you are using Siemens tools as a part of the Siemens Startup Program. How has your experience been so far, and where have they helped you the most?
We're very pleased with the Siemens NX and the startup program, and we have no complaints at all. It's definitely helped us in jumpstarting our CAD designs, being able to take in models from our customers, export to other customers, and generate the models for our spacecraft. So we're able to make drawings that we can send out to manufacturing, and we're able to make high-quality renders that we can then take to our investors to show them what they're actually paying for.
And are you using any of the simulation tools?
Not at the moment, but we will be getting that capability hopefully within the next few months. But one of the reasons we chose NX is because of the deep integration of simulation tools with the CAD platform.
Let us know how we can help with that, if there's anything that you need. Well, Raul, our time is coming to an end today. I'd like to thank you for joining this conversation.
Yes, thank you for having me. It's been a pleasure.
Well, it was a pleasure speaking with you as well. I feel like I've learned a ton about Arcasys and the business platform that you're developing for space and the infrastructure that is going to allow a lot more people to access space and to have their experiments done in space than otherwise they would have been able to do. So I'm excited to see how you grow, and I'm excited for yourself and the rest of the team at Arcasys. For our listeners, if you want to know more about Arcasys or the space business platform they are developing and plan to build, you can go to their website at www.arcasys.com. I'd like to thank everyone for tuning in today to this episode of our Pioneers Siemens Startup Podcast. It has been an absolute pleasure speaking with Raul. We hope you found his insights on the first ever business platform in space to be fascinating, or just as fascinating as I did. This technology promises to open space exploration to everyone. We know that startups and small businesses are the lifeblood of innovation, which is why Siemens is proud to offer special packaging and pricing for startup companies on nearly all areas of the software portfolio. So if you're looking to take your startup to the next level, please visit the Siemens website, www.siemens.com/software for startups, all one word. Or you can reach out to myself or one of the many partners that we are working with. And lastly, we'd love to hear your feedback on this episode. Please leave us a review on your favorite podcast site or send me an email at kevin.blevins@siemens.com to share your thoughts and ideas for future episodes. We're also looking for ways to improve and provide you with the most engaging and informative content possible. So if there's something that you'd like to let us know about, please do. And thanks again for listening to the Siemens Startup Podcast. And we look forward to bringing you more exciting conversations with the most innovative startups and companies around. This is your host, Kevin Blevins. Remember, innovation truly has no boundaries.